hi everyone. Again, my name is Sarah. I am not here to teach you anything that's going to be useful in your day-to-day. I am originally from Portugal, so if I make fun of Portugal, I am allowed. I live in London, and I hate the Berlin airport with everything in me. That's about all you need to know about me. So, this talk started as to build a Game Boy emulator in JavaScript. This is not the talk that you saw, because this dream died. And I ended up with just building an emulator in JavaScript. So it turns out building emulators is really hard. I think it was one of those things that it's like, I play a lot of retro games and I have a bunch of those little handhelds that you go around to play retro games with. And it was always something that fascinated me. So I was like, okay, I can try to do this, try being the key word. And I got very overwhelmed by doing Game Boys, so I started by doing something much, much smaller, which is what I am here to tell you about. Okay, so first things first. What I'm about to tell you is completely and utterly legal. There's two reasons that I want to talk, two reasons I want to have this slide. One, it looks fucking cool to have this slide in a talk. But two, I think there's a lot of misconception of whether emulation is legal or not. I don't know the precedent for every country. I know Sweden's really chill about internet stuff, or was. I mean, I haven't been cutting up with that. But so the precedent in the US for emulation being legal comes from a company called Bleep. I think it was Bleep. So there was this company that made a PlayStation emulator for MacBooks. In the 2000s, you could play video games on a MacBook. 3 years ago, I tried to play Final Fantasy VII, the original one, and it lagged. So that emulator's dead, as you can see. So basically, they went to Sony and were like, okay, we would like to do this. And Sony was like, 9. They're not even German, I don't know. And Sony was like, no, you can't fucking do this. Can't. So they reversed engineered it and managed to make an emulator that worked for MacBooks. There's a video of Steve Jobs being like, bros, emulator on a Mac, and it's so wild. And basically, what happened was Sony was like, you still can't do this, took them to court. And I mean, the company eventually kind of went bankrupt, but they won the legal case because it was found out that it had no proprietary code that belonged to Sony, so they were allowed to do it. It was covered under the Reverse Engineering Act. So, with all of that said, do not fuck with Nintendo. Just don't. It's not worth it. Even if you're right, they will take you to court. You will be extradited to the US, and you're not even American. Doesn't even matter. And I'm not a lawyer, obviously. Okay, so what is emulation? Who in here has used emulation devices, whether that be for games or... Cool. You're all going to jail. Okay, so emulation, there are two different types, and I want to go over that real fast. So there's hardware and software emulation. Hardware emulation is when there's something called FPGA, which basically pretends to be the console on a chip level, which is not what we're talking about. I have not reached this level in my learning. And then there's software emulation, which is what all of these emulators are usually made of. RetroArch is just a bunch of crap code. All code is crap, not just RetroArch. But the point is, you're basically being like, okay, here's this, pretend to be a PlayStation 1, pretend to be Windows 95. This is all of the instructions that you get. Just do the thing that this console would do, including crashing sometimes. Mostly including crashing. Okay, so a lot of interesting emulators, for example, the Dolphin emulator, I think is really interesting because it does Wii emulation from nunchucks and stuff, which works better than the actual Wii. Because I guess you're supposed to have put the thing on top of your TV, but the TV's too thin now. So it has to be on the bottom, and so I'm like, come on, Sonic, god damn it. Don't play Sonic Rings. Why in JavaScript? Why not? It is most likely the worst language to do this. And not because JavaScript is bad, and when I say JavaScript, I mean TypeScript as well. And not because JavaScript is bad, it's because a lot of emulation is very low level. And JavaScript is the opposite of low level. So JavaScript, I'm gonna be honest, is not the best thing, but it's like, okay, if you know JavaScript and you wanna take on a challenge and you wanna learn some bitwise operations and all of that stuff that you can technically do, great place to start. Okay, so the emulator I built was for something called Chip 8. Chip 8 is not really known for anything else other than being the first emulator that EmuDev baby makes. They don't really it was like a fake console, like if you've heard of Pico-Wade, is similar, but from the 70s. It's like a fake console that was made mostly for people to experiment with and learn how to emulate so they can go on to greener, bigger pastures and get sued by Nintendo. So yeah, that's what we're gonna be using. It is not a very well-known thing, and it's mostly it's very good for testing this kinds of thing, like understanding how it works, what it does, all of that. So most consoles / things in general that include electronics are divided into 4 things. You have your hardware, which let's say your microprocessor, or your macro, no, I'm kidding. Like your motherboard, your microprocessor, all of that. You have a screen, which may be embedded, like a Game Boy, or it may be your TV, or it may be 2 screens. Who knows? But you usually have at least one. You have a keyboard or a gamepad, or whatever the fuck the nunchuck was, and you have sound, right? So whether that comes from the TV or not, there's a sound chip in it that makes the beeps and the boops, and that's mostly it. Right? It doesn't have a disk drive, but also let's be honest right now. None of them have a disk drive. So yeah, that's about it. You have the cartridge readers and stuff like that, but other than that, if you think about a console, this is the main idea. You need to be able to input things, it outputs it, you click on the clickies, and it makes the beeps and the bops. Okay, so let's start with the screen. How do you even emulate a screen? I started with this because I think this is the one that makes the most sense in JavaScript, right? So if you think of a screen, that's a canvas. Canvas is a real thing that exists in JavaScript that no one wants to touch because the API terrifies us. So I had to do canvas. So when I started this project, I started with the idea of making a Game Boy emulator, and swear to God, the most terrifying thing to me was drawing Mario on a canvas. I was like, God, this is gonna be terrible. I'm gonna spend days doing this, weeks, months. But turns out the way most of these work, and including Chip 8, is that you have a set of sprites, whether those be 8 by 8, 16 by 16, or 3000 by 4000, doesn't matter. And these sprites are put into the canvas. So you don't actually draw the elements, you just put the sprites. I still did not make a Game Boy emulator, so that didn't help very much. But that's how that usually works, which I think kind of calmed me down a little bit, and I was like, okay, so I don't have to draw Mario, that's great. Yeah, so the screen in the Chip 8 is supposed to be 64 by 32, which basically makes it imperceptible to the human eye. I also have really bad eyesight. I was supposed to use glasses. I did while I was a kid, because when I was growing up, and I don't know why I keep telling this story, but when I was growing up, I used to walk around the house with this eye in the middle, because I have you can't see it, but it's cursed. And my mom, bless her soul, took me to the witch. And the witch told her to take me to the hospital. And yeah, you should visit Portugal, it's a great place. My hometown has 2 churches and 1 ATM. Which I think now makes sense with all the youth and the paying with the phone and stuff. The youth, oh my God. But yes, you should visit Portugal, great place. So, and it's also monochrome, which makes it much easier for you to attempt to do things with canvas. You don't have to care about the color. It's just is this on or is this off? And you just choose a color, right? It doesn't matter which color it is because it's monochrome. You can make it red and green or red and blue and yellow. There we go. And all of that works. So, okay, so we create a class name, we call it screen because it shows the screen. And then this is the size of the screen, so we have an array of 32 by 64, and then we just fill it with zeros. So the way that I thought about doing this, and the way that I saw a lot of people doing it, is that you have all of this is zeros, and then when it wants to toggle something, it just puts it at 1. So the color doesn't, in this case, the color doesn't really matter. It's is it on, is it off? Does that make sense? I can't actually see anyone. So, and then we just assign the canvas to the all of the constructor stuff, get the context of this canvas, and set the colors. As you can see, I just did black and white. You can do whatever cursed thing you want. that's fine. And the scale is basically, again, 64 by 32 is imperceptible to me. So I added a scale of like 10 so that it's... Okay, so then the width is the columns versus the scale, and the height is the columns versus the rows versus the scale. So, yes. So now we have a canvas. Cool. How do we actually show something on the screen, right? Like, we need to create a function which will get an X and a Y, and will actually put a pixel on the screen. So yeah, we get exactly what I said. So the pixel location, we get X and Y and multiply by the columns, and then basically this is, and we'll get into this, it's an XOR, which is a bitwise operation, and it basically does that in this location. If it's on, turn it off. If it's off, turn it on. Right, that's it. And then we return, is it on? Cool. So, good thing about sound in chip 8 is that there's only one sound, so only one beep, no boops. Don't have to worry about boops. Web Audio API scares the fucking living hell out of me. So, one beep only. Cool. So that's cool. So we create a speaker and we create the audio context for this speaker. We create an oscillator which we set to null so that we can actually initiate it and make the beep. Wait, did I say beep or boop? Beep. And we create an audio context. So all of this makes sense. We create gain and create a destination and then just connect all of these things. So basically this is all just like boilerplate for using the Web Audio API, right? I feel like a lot of this is just like, so you have to get the context of the canvas. I don't even know what accent that was. That wasn't, get the context of the canvas. Okay, and how do you play the beep? You know, the aforementioned beep. Okay, so if there is no oscillator, it means that it's not playing, right? Because we initiated it to null, and when we stop it, we basically set it back to null. And in this case, we create one, and we set value at time, which is just, this continues. We just basically say at this time, set this, and we set a frequency, which in this case is just always 440, and we play it. That's it, right? I mean, there's the type, blah, blah, blah. You connect everything, and then you play it. But like, the problem with this is like, if you go on to greener pastures, right, and you, let's say, make a Sega emulator, there's a lot of frequencies, and there's a lot that you need to know. So all of this data that I, like, the 440 is not just a magical number that I picked. I mean, I guess it is because I picked it up from the internet. It's a magical number I got from the internet. Because all of chip 8 is open source. The French made it, God bless them. Okay, so the CPU. So this is an 8-bit CPU, and what being an 8-bit CPU means is, so let's say the NES and the SNES, the main difference, one is 8-bit, the other one is 16-bit, which means 8-bit only allows numbers up to 256, 16-bit, I genuinely forgot, but it's higher. So much higher. So it allows for way better computation. It usually allows for like bigger sprites because it can do all of this stuff way better. So in this case, it's 8-bit. So numbers up to 255, I mean 0 to 255, and we have 4,096 memory locations. And we have 16 8-bit data registers. So data registers are basically, just think of it as a const that you can plop anytime. You can go there and plop the data and show the data. So let's say, what is your score? What is your high score? Stuff like that. That's where it usually gets saved. So in this case, you have 16 cases, consts, whatever. So this is the game. So this game is completely open source, CC0, and it's basically a breakout clone. And basically, this does not play. We will show you the game at the end. Create anticipation. Groundbreaking stuff right here. But the point is, like, I got this, and I got the ROM, which was completely open source, and I saw that the code was like, I think C80 assembly or something like that, which was the same thing that people used to make Game Boy and NES games, in most cases, and I was like, okay, so as a baby emulator dev, I was like, okay, so I just have to go through this code and be like, okay, if you were JavaScript, what would you do? That is absolutely and incredibly incorrect. So if you read this, you have to read it as a unit 16 array, and you get this, which is just a bunch of numbers. As you can see, all of them are smaller than 255, but also, TypeScript can't help you anymore. This is just numbers. Yeah, it's an int. Great job. It's an int array. So this is what you get, and all of these things mean, so when you receive this, all of this means different things for the emulator. It's like, let's say, let's say 19, this is not real, I will show you real, but like 19 is clear the screen. 24 is put a pixel on this part, right? So all of this stuff is just different executions that the emulator needs to do. So you can imagine how big it gets for like, a PlayStation 2 game or something like that. Okay, I don't even think about a PlayStation 5. So all of this, oh, sorry about that. All of this is a little inefficient. So a lot of what people use back in the day, and to read this, is something called hexadecimal notation, which basically turns numbers into other numbers. This was a very fun project. Okay, so it basically turns numbers into other numbers. So everything that you know and use, not know, like that was everything you know. No, everything you use usually is a base 10, right? It's like 0 to 9, and then it goes around. Hexadecimal notation, so that it takes up less bits, goes from 0 to 15, so 0 to F. Yes, it's like high school when they put like letters in your math. But trust me, I failed high school 2 times in the same year at math, and I'm here. That's it, I don't have any, you're not supposed to learn anything from that. I just wanted to make sure that everyone knew. Okay, cool. So decimal 0 to 9, hexadecimal 0 to F, so 0 is 0, F is 15. So this, from my research, was mostly done to save on space, because if you did 11, for example, you would have to have 2 different digits, and like this, 1. So less bits with your bytes. So when I was thinking about how to actually show hexadecimal notation, I was like really struggling, and my partner was like, why don't you just use colors? And I was like, God fucking damn it. That makes a lot of sense. Why didn't I think of that? So hex colors, I think, are the most known usage of hexadecimal notation to this day. Like we use them every day, right? So when you get white, for example, is FFFF, and then when you turn it back to RGB, it's 255. So, yeah. Yes, I confused the white and the black. Failed math. Okay, so let's say you have this color, right? How do you go around to actually making this into a number that makes sense to us? You divide it into its own nibbles. So this is a great name. I'm sure there are other names to describe this, but every 2 sets is a nibble. And that brings me joy. That brings me joy. I live in the UK, I need this, okay? So, joy, nibbles. Cool, so then you get BA and do this whole complicated math of being like, okay, you're at position 0, so it's just like 10 times 16. And that's about it, right? Because A is 10, and then you just multiply it by 16, so you get the value that it's supposed to be. But if it's at position 1, then it's like at the power of whatever position it's at. This is, I don't think I'm doing a very good job explaining this, but if you go through like a couple of them, it will start to make a lot more sense on how it's done. So then you just do 11 times 16 and then 10 times 1, which gives you 186. You can do the same thing for the rest, and then we'll get to 18, and then we'll get 85. So, which means that we just turned this from a hex notation to RGBA, and the RGBA notation, which is 0 to 10, is 186 to 1885, which gives you the badass color, which does not look badass at all. This is the saddest of, I don't actually know what this is. This green or yellow? Something. Okay, cool. So we know about hexadecimal notations, and now we know that we have all of these instructions that we get from the ROM. And every 60 seconds, so we fill in the CPU with all these instructions, and 60 times per second, we need to go through them and see, what the hell do you want me to do? Please help me here. Okay, so we have instructions. What next, right? God damn it. There we go. Okay, cool. It all turned out okay. So this is Wikipedia. So basically the idea is all of the instructions for chip 8 are freely available online, and you can actually check them out at Wikipedia. There's a bunch of other sites, but I just chose Wikipedia because it's Wikipedia. So you can see that these are all of the instructions that you get, right? So 0NNN just means, okay, call this at position NNN. and n is just a random number in this case, right? Okay, so these are all the instructions you have, and it actually tells you, okay, what is this supposed to do? So what do you do in this case? You just basically have to go through every single instruction. This is so bright right now. I can see everyone board, which makes sense. I mean, look at what I'm showing you. So you have to basically go through every single one of these instructions and be like, okay, I need you to do that. And you can think of it as functions because you have things like this, right? I mean, actually, this one is a better example. No, this one is a better example. So it has 5x, y, 0. This means that both x and y in this case can be anything, which means it's basically like a function where x and y are the parameters. And x and y are just a part of the nibble that you get. We'll get into that. But yeah, I hope this makes sense. This doesn't make any sense. You know what? And there was a guy there that did like, and I'm like, that's fair. Be honest, be honest. So yes, you have to go through this and make sure that like everything is doing the thing that you want it to do. So now, oh, so much better, I can't see you anymore. It's like I'm talking to myself. So, and now we tell the computer what to do. So we know what it's supposed to do, kind of, from reading Wikipedia, and now we have to be like, okay, no, actually you need to do this when you get this instruction. Okay, so let's create a function on a CPU class that's called execute instruction. And every time we do this, we increment the PC by 2, because every instruction counted by 2 bytes, because each instruction is 16. Okay, we increment the program by twice. And then we extract this. And you're looking at this and you're like, what the fuck is that? I have prepared. So let's talk about bitwise operators. Which is something that I remember specifically that I was trying to learn this a while back ago, and I was at some random ass coffee shop in London having a coffee and just looking at this and being like, what the fuck is this? Bitwise operators. So we're gonna go through them first in binary because it's just easier, because if you look at binary, it's just at base 1, so it's either 0 or 1, either on or off. That's it, right? So if you have an AND operator, it basically means AND. So 1 and 1 equals 1, 1 and 0 equals 0, because an AND operator needs both things to be true. An OR operator is the same thing in JavaScript, as you know, so it's like if 1 is 1, then both of them are 1, it's fine, we don't care. And then we have this operator, which basically means the opposite. So it's an XOR operator, so it basically like removes it, right? It's like if any of them are this, then we remove both. Okay, so, and if we look at hex now, if you have something like FFFF, and you give it F000, we know that these ones are 0, so they basically need to be removed, right? And all we care about is this. So this is the only one that matters to us, because it's the only one we managed to get it from the number. Same thing here, so any, and then in here, you can see that it's the opposite, so any that's true, any that's false becomes true. Okay, cool. This is probably one of the most complicated parts, and we're almost at lunch. We have 6 minutes, and then you're all free to go. I mean, you're also free to go now. I'm not keeping you here. My upper body strength is very low. So, okay, so what this means is that we only care about this number, right? And then we just get it. This basically just says, like, move it so that we can find it. And this becomes the X value that we talked about before, right? And so we switch on this opcode and get this value as well, and then we just say, okay, if whatever returns from here, all of this is equal to 9e. Also, this 0x basically means we want this to be hexadecimal, and this is how JavaScript can understand if it's hexadecimal or not. And it checks, okay, is this keyboard key pressed? If it is, then do something, right? So you basically just have to do this for every single opcode. So it's more about it like a persistency thing, like being persistent about it and going through all of them than anything else. So for example, the sound timer, again, it's either 0 or 1, but in this case, we basically find, okay, so we have all of these registers, we get X, and then we say, if it turns out to be 018, then the sound timer is equal to this, and which is a value in the registers that are set by default when you start. Cool. And then you have stuff like render clear, which is one of the first ones you see. So you get this, and you see, okay, does it match 0, 0, and everything else? Does it match this? If so, clear the display. So all of this is just going through all of these things and making sure that we do exactly what the the console wants us to do. Does this make sense? Thank you. Thank you for everyone that said yes out loud, because I can't see anything. And now let's look at all the code. It's not scrolling, is it? Oh. Okay, I can just scroll myself. As you can see, it's just a huge ass switch statement with switch statements inside of the switch statement. Switch statements are not dead. No, but in all seriousness, I fucking love switch statements. I mean, not that one, that's cursed, but in general. Okay, so now the emulator. I'm gonna show you some really basic stuff. So this is a JPEG. Everything else is canvas. So this is just the breakout clone, and it works. It works really badly, but it works. I think I'm also gonna be on time and give you some time to get food. Oh, I forgot that he did this. Okay, yes. Okay, cool. You can install it if you want. I don't know why you would do that, but you can. There's a bunch of comments that I wrote with the help of Copilot. Everything else, I actually wrote it. It was just like, the comments, sir. So that like you can go through it and basically see like, okay, why is this doing this cursed ass thing? So you can install it if you want. I don't know why you would, but I hope you do. And yeah, 3 minutes left. Thank you so much. If you want to see my slides, and that's my blue sky.